Hello again. This is a question here showing you how an object basically is moving, increasing in velocity at 20 meters per second. And you can see that time taken for it is going to be 5 seconds. Now, in order to show what is going on, we have got two keywords here, first of all, describe and calculate. So the first question that students normally ask me is that what is the motion of the object like? Well, we can see from here that because we've got a diagonal line, we can say that the velocity is increasing from 0 to 20 meters per second in 5 seconds. Now, we would say that this object is actually moving with uniform acceleration. And the reason why it's moving with uniform acceleration is because the object is increasing in velocity at the same rate. So we can see from here that once we calculate the uniform acceleration, simply to calculate the uniform acceleration, we have to do this, where we have acceleration is equal to the final velocity minus the initial velocity divided by time taken. And we can see from the calculation that the final velocity at this point in time here is going to be 20 meters per second, and then the initial velocity is going to be 0. So when we plug these values into the calculation, we can have 20 minus 0, divide that by your time taken, which is 5. In a sense, we are going to have an answer where the acceleration is going to be equal to 4 meters per second squared. Now from this, we are able to calculate a number of different things here. Not only we can calculate the distance travelled, because simply the distance travelled is going to be the area underneath the graph. And to show that, we can actually then focus on looking at the area underneath the graph. And remember, one of the key things you must remember is that in order to work out the distance travelled, it's going to be this particular area here, where we have look at the area underneath the graph. And because we've got a shape of a triangle here, we can say that the distance travelled is going to be equal to 5 times that by 20 and divide that by 2. In a sense, what we have is really, we're going to have here 50 meters travelled altogether. Now, this is two things that we've calculated so far. Number one, we calculate the acceleration using this formula here. And in order to do this, we looked at the graph where the graph extends from 0 meters per second up to 20 meters per second in 5 seconds. Not only have we got an increase in velocity, we also understand that it's uniform acceleration here as well. Now, the next thing that we can look at now is how do we calculate from this information, how can we calculate the force required in order to increase the velocity from 0 up to 20 meters per second. And to do that, we really need to focus on a couple of things. And number one, we need to focus on looking at the equation of force linking mass and acceleration. And to do that, we have simply got Newton's second law of motion that specifies that the force is equal to the mass times that by the acceleration, where we have force is equal to the mass. Well, the mass is going to be 3 kg, as you can see, and because it's 3 kilogram, you multiply that with acceleration that we worked out, which is 4 meters per second squared, and that simply gives you a force of 12 newtons. Now, to make sure we understand this, in order to summarize this, we started off by looking at a calculation where we were given a mass, where we were also given an increase in the velocity using a velocity time graph, and then from that we then calculated the acceleration. Then once we calculate the acceleration, we were also able to then plug this value into Newton's second law of motion, where this m value is going to be measured always in kilograms, and this acceleration is always going to be measured in meters per second squared. And from this principle here, then we are able to obviously turn the handle and get the value for force, which is 12 newtons altogether. The last thing we looked at was looking at the distance travel. Distance travel is simply going to be looking at the area under a velocity time graph. this is enough of sample physics here right now, and I will look at another aspect of this topic in the next video. Many thanks.